Hello and welcome to our group's assignment 3 video for Computing Technology Innovation Project. My name is Presley and I handled the site architecture and designed 3 of the pages which I'll be showing briefly. So overall with the site architecture, it's all structured using React Router for easy navigation. We've got a fixed header that follows you as you scroll, making sure that's always visible in case they want to go to any page. We've got a try it now button just below the description. If users decide after reading the description they want to go straight to the tool. And just below that we've got 3 big bold statistics. This provides an eye-catching effect for anyone who views the website. Then we've got a simple 4-step process that explains how it actually works. The reason why users should use our model, and a call to action button at the very bottom. So it'll take the user straight to the model as well. Across this page we've got hovering effects on the cards as well. And yeah, I'll go towards the spam detection model. William will go over this more in depth, but just to be really brief, it's got a spot for the text to be pasted, and then users can upload their file and press detect spam. For our about page, we've got descriptions for each member, as well as a major with photos of each member. We've got the reason why we built this model, what our system actually does, and then the machine learning approach we used with the 93.95% accuracy. And it's also another call to action at the bottom in case they want to go to the model after reading the about page. In terms of technical implementation we've got here, we have CSS in the background with a gradient background that shifts using keyframes over 13 seconds. And it's very subtle, but it's a fade slide animation. For our about page and other parts of the website, it's adjusted so that if a mobile phone was used, it will change it to columns instead to make it easier for this for visual visibility. And yeah, I'll hand it over to William and he'll be going through the spam detection model page in more depth.
Hi, my name is William and I'll be demonstrating how the spam detection model page works and how I implemented the backend API using Fast API. So as Presley said, we've set up the page to take a user input in 2 different ways, either by copy and pasting email text directly, or by selecting a file. As you can see, the results of each test are being displayed just below the detect spam button, which allows users to see the results of previous tests, and to expand result cards to view a chart displaying the model's confidence in its result. This web page communicates with the server's backend via Fast API. It does this by implementing this script that I wrote. This script tells the Fast API backend what to do with information received from the post requests sent by the site. This function in the JavaScript code for the website handles the input from the user. It first detects and stores user inputs, either from the text input box or from the file input, and stores it as a variable to send to the backend. Input files are validated at the point of selection due to the fact that users can only select EML files, which our Python script knows how to interpret correctly. But just in case the file is invalid for any other reason, such as corruption, the script will also run a check here. Clicking the Detect Spam button will send the stored data off to the model via a post request. Backend API imports methods for communicating with the AI model, which we developed in Assignment 2. Dylan prepared our Python script for usage via the API by setting up a variety of cleaning and processing functions so that it can properly interpret input, which we'll be discussing shortly. I also put together the explanations and visualizations page. Here we just describe in simple terms how we developed and trained the AI, and why we decided on the solution which we used. I included diagrams detailing the flow of information, links to the datasets used in training the AI, and the confusion matrices of the various methods of implementing the model, showing why we chose logistic regression in more detail. I'll pass you over to Dylan now to explain the functions he set up to pass input data into the model.
I'm Dylan and I handled converting the logistic regression model from the previous assignment into a Python package. I first saved the trained model from the previous assignment into a pickle file using joblib. When a new instance of the package class is created, this file is loaded to be used for the predictions. By default, the prediction function will run the input data through the cleaning function, which processes the data the same as how the training data was processed. The cleaning data is then run through the model's prediction functions to get and return the binary determination of if it's spam or ham, as well as the probability of each class. That concludes our AI model integration demonstration. Thank you for watching.